Welcome to the Oracle to Snowflake migration presentation. The purpose of this presentation is to provide the high-level methodology needed to prepare for and execute the migration of an existing Oracle system to Snowflake. To prepare for the migration, there are several things to consider. The list on this slide outlines the initial objectives. Plan not to migrate Oracle-specific schemas like sys, sysaux, anonymous, DBSNMP, etc. These are Oracle system schemas that aren't needed in Snowflake. If you are not sure which Oracle database schemas to exclude, Oracle Database 12c introduced the Oracle_maintained column in the DBA_users dictionary view. The column will have a value of Y for any schema that was created via Oracle scripts. Avoid moving unused objects unless they are needed for audit and historical purposes. Snowflake uses role-based access controls. Therefore, documenting existing Oracle users, their roles, and permissions is required. This allows you to replicate the data access and security strategy implemented in your legacy Oracle system. Pay special attention to sensitive datasets and how they're secured within Oracle, as well as how frequently security provisioning processes run in order to create similar security within Snowflake. Finally, you will want to ensure that you have an existing as-is architecture diagram of the existing Oracle solution. Establish a migration approach by listing processes to migrate as is, processes that need refactoring, and broken processes that need to be fixed. Draft these deliverables and create the to-be architecture diagram. Snowflake generally recommends minimal re-engineering for the first iteration, unless your current system is truly broken. The more rework that is done, the more development and testing will be required, which will most likely lead to a longer migration project duration and higher risk. In order to provide value for the business as soon as possible, avoid a single big bang deliverable as the migration approach, and instead break the migration down into incremental deliverables that enable your organization to start making the transition to Snowflake more quickly. Your organization may want to change your development or deployment processes as part of the migration. Document new tools that will be introduced as a result of the migration, tools that will be deprecated, and development environments that are needed for the migration. Whether the development and deployment processes change or not, capture the development environments that will be used for the migration. For example, pre-prod and prod, dev, QA, and prod, and the development processes, source control repositories, methods for deploying changes from one environment to another, for example. These will be used for that migration. This information is critical to direct how the development and deployments are implemented. The ideal candidates for starting the migration combine providing value to the business and minimal migration effort. Rather than starting with the most complex data sets, begin with a simpler data set that provides a quick win and establishes a foundation through the development and deployment processes to build the rest of the migration from. To prioritize datasets for migration, careful attention needs to be paid to understanding the process dependencies of the datasets. Those dependencies need to be documented. The better that process dependencies are identified before beginning implementation work, the fewer blockers occur when additional dependencies are identified during the migration. Ideally, this documentation can be captured using an automated process that iterates through the existing job schedules and captures the data within Oracle, rather than depending on manual work to identify and document changes. Creating an automated process provides value throughout the migration project by more easily identifying the ongoing changes that occur throughout the migration project, since the underlying systems are unlikely to be static during the migration. As part of the preparation phase of a migration, resources need to be identified. Some common roles needed for the migration are developer, quality assurance, business owner, project manager, program manager, scrum master, and communication. When a Snowflake solution partner is engaged for a migration, they may fulfill multiple needs, including solution design, requirements gathering, documentation, development, testing, delivery, and training. The expectations as to when a migration should be completed are an important input into the planning of the migration, but they need to be combined with other information that has been gathered in order to determine whether the deadlines can be met. One of the benefits of gathering all of this information is to establish and communicate achievable deadlines, even if the deadlines are different than what the business expects. It is common for migration deadlines to be set before evaluating the scope of the project to determine if the deadlines are achievable, especially if the business is trying to deprecate a system before a renewal date. In situations where the deadline can't be moved and the migration scope requires more time than is available before the deadline, work needs to be done with the business to agree on a path forward. Understanding the budget that has been allocated to complete the migration is also critically important. The amount of migration work and the cost associated with the migration work needs to be compared to the available budget to ensure that there are sufficient funds to complete the work. Pausing in the middle of a migration or stopping it altogether is a bad outcome for all involved parties. A Snowflake representative can provide a template and work with customers to capture the virtual warehouses that are needed to do the work, i.e., ETL or ELT processes, reporting, and visualizations. The template calculates the number of minutes a warehouse is expected to run each day and the number of days a warehouse is expected to run each week. Once the template is filled in, it will provide estimated annual costs. Migration outcomes should be used to validate that the migration project is providing the overall benefit the business expects to achieve from the migration. For example, if turning off an Oracle database system is one of the desired outcomes, that outcome should be achieved by the migration plan. This documentation can be expressed as success or failure criteria for the migration project and may also include benchmarks that compare process execution on Oracle and Snowflake. Once compiled, this information should be used for communicating the wins of the migration project to stakeholders. After identifying differences between Oracle and Snowflake, present them to the business along with mitigation strategies that are available and confirm with them that the proposed approach will meet their requirements in order to set appropriate expectations from the beginning of the migration. The escalation process needs to be documented, who is responsible for working on the issue, who is responsible for communicating the progress of the issue, and a list of contacts from the business, Snowflake, and any other involved parties that are involved in resolving the issue. Please be sure that everyone has access to and knows how to log a support ticket in the Snowflake portal. Likewise, they should know how to ask questions and find resources in the community forums. Publish results to stakeholders so they are clearly understandable and the benefits of the migration and their time and money was well spent. Depending on the security requirements, there may be a need to capture role creation, user creation, and the granting of users to roles for auditing purposes. While the existing Oracle database security can be a good starting point for setting up security within Snowflake, the Oracle security model should be evaluated to determine if there are roles and users that are no longer needed or should be implemented differently as part of the migration to Snowflake. Additional roles may be required for restricting access to sensitive data. Develop a test plan by identifying the appropriate level and scope for each environment. For example, schedules aren't executed in dev but only in QA and prod, and data comparisons between Oracle and Snowflake occur only for prod. Automate as much as possible to ensure repeatable test processes with consistent output for validation purposes, and define, agree to, and document acceptance criteria. Preparing Snowflake for loading during an Oracle migration may take on several challenges. With the multi-tenant architecture of Oracle Database 12c, each pluggable or tenant database may translate to one or more Snowflake databases or schemas. If the Oracle database is a single tenant, then multiple users may map to individual Snowflake schemas. Please be aware that since the Snowflake database contains the environment in its name, that any views that reference a database name in the view definition will need to be updated as the view is deployed from one environment to another, for example, deploying from QA to prod. There should be a separate data warehouse for each environment, dev, QA, and prod, and for each function that the virtual warehouses will support, For example, a separate warehouse for ETL or ELT processes, reporting visualizations, and data science. As the databases and database objects and virtual warehouses are created, they should be assigned to the appropriate security roles. Depending on which Oracle environment the data came from and which Snowflake database is being populated, there may be an opportunity to use cloning to move data within Snowflake from one database to another, which will require fewer resources than loading the same data multiple times into different Snowflake databases. Develop processes for the extraction of data from Oracle to S3 and S3 to Snowflake. As this is bound to occur multiple times during the testing phases, automated and repeatable processes will expedite this exercise and deliver a high level of consistency. It is advisable to begin with a subset of the data from Oracle rather than trying to load the entire contents of the Oracle database at the beginning of the migration. After an initial load of data is complete, generally a subset, creation of new processes or modification of existing processes may be required to keep Snowflake updated with data changes. These processes should be scheduled and take into consideration the appropriate process dependencies. The state of the data loading should be clearly understood and communicated. For example, loading is in progress, loading is completed successfully, load failures occurred that need to be addressed. Finally, begin comparing executing timings between Snowflake and Oracle to ensure that SLAs are being met. Once a sound and repeatable initial load and update process is in place, testing can begin. Perform initial data comparisons between Oracle and Snowflake. Row hashing can expedite this by concatenating all columns in a row and hashing that value, for example, using an MD5 hash. This will allow quick identification of discrepancies. Continue to perform timing exercises between Oracle and Snowflake and share these results with stakeholders. Additional groups should be engaged after initial testing is completed that validates the data is ready for further scrutiny, so that the first exposure these groups have to Snowflake isn't with obvious incorrect results. Any known reasons for why data won't match between Oracle and Snowflake should be documented and shared with the groups who are testing so they don't spend time researching previously identified issues. As business units are engaged in testing, Oracle and Snowflake should be running in parallel to ensure continued validation of data. To facilitate comparing data between Oracle and Snowflake, there may be a need to create hashes as data is extracted from Oracle, which can be used for comparing data at the row level between Oracle and Snowflake. These comparisons should take place in Snowflake, where resources can be provisioned to compare data without negatively impacting the Oracle system. Attempt to minimize the time the two systems are running in parallel while still maintaining sufficient validation processes. Up until now, the migration process has been focused on raw data comparisons. Next, update tool connections, visualizations, and ETL or ELT tools, for example, to point to Snowflake. Validate the connections are successful. Copy any solutions that point to Oracle and update them to point to Snowflake and compare the output as part of your validation process. After the business units have validated their tools are producing required results, a cutover to Snowflake can begin. Schedule and communicate the cutover plans with all stakeholders. Once the cutover is complete, users should have the ability to log into Snowflake and to run the tools they depend on, which are repointed to Snowflake, and Oracle database access should be revoked. Thank you for listening to the Oracle to Snowflake